So yeah, good evening. In this class, we'll be looking at this AWS analytics. So analytics is something it is a analysis tool for with the clients or the application managers and all, or even this AWS analytics tools are used by this AWS to manage all their resources. So today we'll just have a look on this analytics. So there are a lot of services under this analytics. So the first one is Athena. Athena is a query data in S3 using SQL. So here in Athena, what actually happens is so yeah, this is Athena. So in with this Athena, we'll be dealing with the data in this S3 with this query SQL with the queries in this SQL language. SQL is nothing but a structured query language. So this Athena is fast, cost-effective, interactive query service that makes it easy to analyze petabytes of data in S3 with no data warehouse or clusters to manage. So what it do here is, if in order to maintain or manage a bulk amount of data or large data, usually yeah, there's a need for this data warehouse. But with this Athena, you don't there's no need of having or maintaining any warehouses. Instead, you can just manage them with the simple, this structured query, with queries in SQL. So here, the process with the Athena is you have to select the data set, and then you have to create a table there, and then you have to query your data. So for selecting this data set, you have to identify where your data is located in S3. So first of all, you have to put all your data in this S3, that is uh, this Amazon storage. So this Athena allows you to query data in CSV, TSV, JSON, paragraph, and ORC formats. So this these are all the file formats. So we may have our data either in this CSV or JSON or ORC formats and all. So this CSV is nothing but this comma separated values, which we'll be having this extension for the Excel sheets. For creating a table, use the create table wizard or write down your own DDL statements using Hive. So this DDL stands for data definition language. And for querying data, you'll be running queries on your data. So this Amazon Athena supports ANSI SQL queries. So in order to handle, in order to access your data, you'll be just writing a small query. So for this tables and database creation process in Athena, you can run your DDL sequence in Athena console using JDBC and ODBC driver, or using the Athena create table wizard. So when you create a new table schema in Athena, this Athena stores the schema in a data catalog and uses it when you queries. So this stores a schema in the data catalog and uses it whenever when you run queries. And Athena uses an approach known as a schema on read, which means which means the schema is protected onto your data at the time you execute a query. So this eliminates the need for data loading or transformation. So yeah, that's how we'll be dealing with this Athena. So Athena is nothing but just yeah, it's a query data, or it's type of query is nothing but questions with given conditions. So this Athena is a query data in S3 using SQL. And the next one stands for and the next one is EMR. EMR is managed Hadoop framework. So yeah, EMR stands for EMR stands for Elastic MapReduce. So this is a web service that enables business researchers, data analysts and developers to easily and cost effectively process vast amount of data. So you do not appear to have any clusters. So you can you will be creating these clusters to organize or arrange your data with some similar kind of properties. So how it works. So firstly, we'll be uploading our whole data and then create and configure your cluster by specifying the data inputs. As we are having a large amount of data, that is this bulk amount of data. So, as we are having this bulk amount of data, we have to configure and create our clusters by specifying the data inputs, based on what your table is working, or based on what the whole system is running. And coming to this monitor, so this monitor monitors the health and progress of your cluster, retrieve the outputs in S3. So yeah, coming to the next one is cloud search. So this Amazon cloud search manages all the server resources needed to build and deploy search indexes. So all you have to do is to upload your data to a search domain and start submitting responses. So you have no search. For some zones, they'll not be having their search domains. Even in Azure, having it. So yeah, even this is it's not available in our zone, that is there's Mumbai. So now so coming to the steps, how do we use this cloud search? So firstly, you have to create and configure data for a search domain, and then upload the data which you want to search, and send search requests to your domain. So then it will be processing your request and then giving you the perfect output. So once you click on this create new domain, this is what the page which appears. So here then you have to give your give all your details, from from the domain name and even to the setting up this access policies and all. So yeah, like once after you fill this thing, and then you'll be redirected to this configuring index, and then renew index configuration, and then setting up these access policies, etc. And now we are going to look at this Elasticsearch service. So with this Elastic search service, it makes it, this Amazon is making it easy to set up, update, and scale and Elastic search clusters in the cloud. So firstly, you have to create a domain page and purchase, reserved instances. So, firstly, then you have to launch an Elasticsearch cluster, and then you have to manage and monitor your cluster, and you will be loading and querying the data, and then purchase this reserved instance. So this is how this work, that is this Elasticsearch works. So yeah. And finally, coming to this kinesis. So this easily, collects, process, and analyze video and data streams into in real time. So you can get timely insights and react quickly to new information. So what can you build with this kinesis? So you can evolve from a batch to real-time analytics. So this is how it's you can just see it. Here we are giving this input, and then our output is you know uh, converted. Sorry, the operations are convert or carried out in this real time. So input, you can see the input here, right? So this website sends clickstream data to Kinesis data firehouse. So this Kinesis data firehouse collects the data, or collects the data and send it to this Kinesis data analytics. So this data analytics process, Kinesis data analytics process the data in real time. And coming to the Kinesis data firehouse, load process the data into Amazon Redshift. Kinesis data firehouse. So this loads processed data into Amazon Redshift. And coming to this Redshift, uh, So this Redshift run analytics models with come up to excellent recommendation, and then we have our output. So these are all the steps carried out before the before delivering this product actually. When coming to this analyzing this IoT devices, so here we have the input. The static sensor sends the data to Kinesis data system that there's a wall or about any hurdle or any actions regarding this robot. So the data will be sent to Kinesis data streams, and then triggered. So this it is being sent to this data streams, and then a triggered event, a lambda, like the event is triggered. That is, this lambda is triggered, and then it will be sent to this AWS lambda. So and then this lambda is a processor, right? So it will be processing the sensor inputs, and then it will be giving them the output like based on uh, the instructions on what to do. And we have this benefits here. It's a real time management, and it's also fully managed, and it's also, and the more advantageous thing is it's scalable. Coming to this data pipeline. So here in this data pipeline, this AWS data pipeline help you move, integrate, and process data across AWS compute and storage resources. So as well as your on-premise resources, this data pipeline supports integration of data and activities across multiple AWS regions. So here, what we'll be doing here is what we'll be doing is you have to define this data node. So you select the input and output data out of this S3, DynamoDB, Redshift, RDS, and JDBC sources. So this schedule completely actives, this schedule compute actives. So they configure and activate the all the uh, they configure and activate that this will process data from EMR, Hive, or SQL and search. And coming to this activate and monitor, this activates your pipeline, and then let AWS data pipeline manage the pipeline execution resources, retry logic, and the failure notifications for you. And so